Hello everyone, welcome to this session. Chapter is simple machines. In our previous video, so the screw jack. So we discussed the structure, the various ways on how you can calculate the mechanical advantage, the velocity, the efficiency of the screw jack. So today let's move on to the other simple machine, that is the wheel and the axle. So this is the other simple machine. We start with the structure of the wheel and the axle. As you can see, the wheel and axle is the simple machine that consists of a wheel and the axle that are mounted with the same axis of rotation, whereby the radius of the wheel is different from the radius of the axle, as the radius of the wheel is always greater than that of the axle. So that's simply how the wheel and the axle is structured. Now, when you're talking about the mechanical advantage of the wheel and the axle, you can simply obtain the mechanical advantage of the wheel and axle by comparing the radius of the wheel, the radius of the axle, using the formula as below, that is MA is equal to RW over RA, whereby in this formula, MA stands for the mechanical advantage, RW stands for the radius of the wheel, and the LA stands for the radius of the axle. So you can find the mechanical advantage simply by taking uh, the radius of the wheel upon the radius of the axle. Now, when you're talking about the velocity of the wheel and the axle, the wheel and the axle works in a way that when an effort is applied to rotate the wheel, the axle which uh, pulls the load is simultaneously rotated, covering the same number of rotations as those of the wheel. Now, in this case, in one rotation of the wheel moves the effort to a distance equal to its circumference. Similarly, the axle moves the load up a distance equal to its circumference. That means as follows: distance moved by effort is equal to circumference of the wheel, while the distance moved by effort also is equal to 2 pi times the radius of the wheel. So the distance moved by effort will be equal to 2 pi r. Now, distance moved by load is equal to circumference of the axle, whereby also the distance moved by load is equal to 2 pi times the radius of the axle. So the distance moved by load is equal to 2 pi l. Now, since we know that the velocity ratio is equal to distance moved by effort upon distance moved by load, now from there, then for the wheel and the axle case, the velocity ratio will be equal to 2 pi r over 2 pi r. The capital R is for wheel, and uh, the small letter r is for axle. Now, these two will be cancelled out, so the velocity ratio will simply uh, get it by taking the radius of the wheel upon the radius of the axle. Now, in terms of the efficiency as general, it is that the efficiency equals to mechanical advantage over velocity ratio times 100%. So that's all how you can find the mechanical advantage, velocity ratio, and the efficiency of the wheel and the axle. Now, let's see the wheel and the axle in our daily life. So you will see the applications of the wheel and the axle in our daily life. The wheels help people to do work in two ways. First, like levels or inclined planes. Wheels, they just allow you to do something easy for a longer time instead of doing something like very hard for a shorter time. Now, if you turn a large wheel, fix it to an axle, the axle will also turn. You can turn the larger wheel easier, but it takes a lot of turning to go all the way around. So simply it helps to work these wheels and the axle. The axle will go around a much shorter distance but with more force, so you can use a wheel, create a mechanical advantage. You can turn something heavy by spinning a large wheel, attach it to an axle that is attached to the heavy thing. So wheel and axle, you can simply basically say that is used in lifting heavy loads, as it simplifies the lifting. That's how take an example, the pencil sharpener works, or you can do with the other way around. There's a lot of force to turn the axle and that will spin the wheels real fast. That's what cars also do. So it is applied in pencils, cars, etc., etc. Wheels are also the most important part of the pottery wheels, wagons, and cars, but also wheelbarrows, spinning wheels, water wheels, windmills, and pulleys. So all these are just the applications of the wheel and the axle. Now, also wheels also on wagon only touch the ground at one spot at a time, keeping the rest of the wagon off the ground. This makes less friction so that the wagon is easier to move than if you are pulling it along like a sled. So that's all I have for this session. I hope that's all clear. Thank you for listening. We discussed about the wheel and the axle as one of the simple machines. We've seen the mechanical advantage. First, we've discussed the structure of this wheel and the axle. Then we've seen the how we can calculate the mechanical advantage versus the efficiency of the wheel and the axle. And we've later on seen the application of the wheel and the axle. Thank you.